Here's problem number 7 from section 7.2. We're going to try to find the area enclosed by the two curves y equals sine x and y equal 1 minus x squared. Let me do a quick sketch of this to see what I think I'm up against. Now, I know that this curve is parabola pointing downward. That is up here, starts here at 1, and something like this. I know that this curve is, of course, the sine curve. It's down here at 0, and it's going to go up like this, and it's going down like this. And it looks like I have two intersection points that I'm going to have to deal with as I try to calculate the area between these two curves. So, if I declare this point here to be where x is a, and this point here to be where x is b, this area looks like it's going to be the integral from a to b with the parabola on top and the sine curve on the bottom. And what's left is for me to find out what a and b are. Well, let's use the calculator to find that out. All right, so I'm going to go into calculator mode. I am going to put my parabola in. I'm going to put the sine curve in. I'm going to use the trig window. Zoom trig, and let's see what that graph looks like. There's my parabola. There's my sine curve as I expected. All right, and let's go ahead and let's find the intersection. Let's find this intersection first. So I'll go second calc. I want to find the next intersection, which is option number 5. My first curve is indeed my parabola. Second curve is indeed my sine curve. And my guess is going to be, I'm going to go -1. And lo and behold, there they found that intersection point. It's when x is equal to -1.409, blah, blah, blah. I'm going to leave this screen for just a second, because what I'd like to do is I'd like to take that value, which was stored in x, and I would like to store that, and I'm going to store it into alpha a for just a moment. Let's go back to the graphing screen and let's find that other intersection point. So again, I'm going to do second calc. I'm going to find intersection, first curve, second curve, and I'm going to guess at 0.5 just so I can get to the right intersection point. And there is my b value at 0.636 and so on. Let me get out of the graphing mode and let me take that value and let me store it into b. Great. So now I can, in my narrative for my problem, I can remark here that a is equal to -1.4096240004, that b is equal to 0.6367326508, and now with those values being declared for a and b, then I can go ahead and find out the value of this integral. Let's go ahead and take the antiderivatives. Antiderivative of 1 is x. The antiderivative of -x squared is -1/3 x cubed. The antiderivative of negative sine is positive cosine x, and I'm going to evaluate that expression from a to b, which will give me b minus b cubed over 3 plus cosine of b minus the value at a, which is a minus 1/3 a cubed plus cosine at a. Now, how am I going to get that value out of my calculator? Well, I'm going to type in exactly that. I'm going to type in that it's b minus b cubed divided by 3 plus cosine of b minus the quantity of a minus a cubed divided by 3 plus cosine of a. That closes the cosine parenthesis. This closes off the parenthesis that's right here. And let me hit enter. And I get 1.670. And since this is my final answer, I'll present that rounded to 3 decimal points. And there's problem number 7.